Okay, this one's quite a tricky one today, but it was inspired by a question that I did with some students recently, and I thought we'd go through it. So we've got a Venn diagram here, and the Venn diagram describes this situation. So students take part in a variety of activities at school. All students take part in at least one. So in other words, it's like a 0 outside. Given. So this was in particular about given questions. So given that the student doesn't participate in activity B, well, when we read given questions, the way I like to do these is I like to reduce the diagram to the parts I'm interested in. So given that they don't participate in B, so that means that the whole question is really only about these parts here. Okay, that's because this whole circle here, anywhere in the circle, it means you do activity B. And we know that the person's not here, so there's no point in us looking at that. We also know there's nobody here. So we've kind of dealt with that bit now. All right. So given that we're somewhere in that yellow zone there, what's the probability they take part in A? Well, the choices are only this bit here, which is like the only A bit, and this bit. The 3 and the 8 are just not possible anymore. They're not possible because I know that it doesn't take place in there, so I can't take those into account. So what's my answer going to be on this one here? Well, it's just the 11 and the 4. So it should just be, what's that there? That's 15 out of however many we find ourselves out of here. So 15 out of, I think it's 15 out of 30, isn't it? As a half. Okay. Now, let's try another one before we go on to some really challenging ones. But this one in itself is really quite a step up. So here we go. So for the second question, find the probability a student does not do activity A and a second who does activity B and C is chosen. Right, so this is the idea of sort of one student and then a second student. So, well, how do we normally represent these situations? We've often represented them with tree diagrams before, haven't we? To sort of say that something happens first and then to say that something happens second. And that's the kind of thinking that we're going to want to do here as well. So, a student who does not do activity A is chosen. Let's do that bit first. So who doesn't do activity A? Well, it's those ones there. All of these people here do not do activity A. So that is 11 plus the 15. So that's 26, isn't it? There's 26 people there that I could be describing. So I've got 26 out of how many total? Let's just work. Do we have that number anywhere? 26 out of 30, 41, 49, 52. Okay, so that's actually half, isn't it? So half. And is kind of meaning here and then. And then a second who does B and C is chosen. Well, there's a couple of things to watch out for here. So first of all, there's the idea that we've already picked someone. So it's not out of those 52 anymore. So that's the first idea. The other part, which is more of a problem than you might have first thought, is it's not certain if this is how I would do it. And the reason for this is when I picked one of these students, we don't know if that student is still around. So what we have to do is we're going to have to consider that, sort of, if you like, the first student does not affect the probability of the second, and that the student also does affect. So what do I mean by that? I mean, well, let's say first of all that I picked the first time round, I picked from one of these. So that would mean, well, it would be, that would be 22 out of 52. And then the next time round, my 12 is still intact. So that's 12 out of out of 51. So this is the case that they're not affected. Well, let's think about the other case. So imagine I had picked this student here. So I'm going to do 4 over 52. Can you see there that that's the same as my 26 over 52? So I'm going to put a 4 over 52 there. So if I pick this one here, well, and then for the next one, this wouldn't be a 4 anymore, would it? It would be a 3. So that's okay. I can just put that now as an 11 over 51. So let's just talk through everything again. So we need to consider that over here, the first time round, although I'm interested in all of these numbers, okay, I am interested in all of these numbers, we have to consider sort of this one and this one as different paths, okay? This one is when it doesn't affect it the next time around. So there are 22 out of 52. And then that would mean, for the second part, I would have 12 out of 51 because one of the students isn't there anymore. Okay, the other one is going to affect. So it would be one of these 4. And it's okay for me to do this separately, yeah? Because ultimately, at the end, I'm interested in these both. These are both separate ways, mutually exclusive ways that this could have happened. So I'm just going to add them together, okay? That's still, that's still that 26 over 52 you saw from before. So if it does affect, then I have to consider that that wouldn't be a 4 anymore. That would be a 3. And that's where my 11 is coming from. Okay, so there are other ways that perhaps you can sort of adapt this question, but the important idea is that we need to go through, we need to map the different possibilities of how, depending on where the student is removed from the first time, it actually affects the probability for the next one.